Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss a new concept regarding similitude type of similarities. Actually, this is also a part of dimensional analysis. So in our previous lecture, we have already discussed regarding the model and prototypes. So the similitude means actually, this is the similitude is actually defined as the similarity between the model and prototypes. So which we have discussed in the last class regarding the model. So like what is the difference between model and similarity? One is model and another one is prototype. So once you create a model and that is a replica of a structure or any kind of designs, you can say either it may be machine or any kind of structures. Before going to be the actual setup, we need to do some kind of models. Then that model will be converted into prototypes. So the similitude similarity should be similar, similarity between this model and prototype should be same. So what kind of similarity should be there? Actually, we have some kind of properties are there in our dimension analysis. We have seen some kind of dimensions like geometrical dimensions and kinematic dimensions and dynamic dimensions are there. So here also the similarity between this model and prototype should be similar or same of what? Of geometrical similarity, of kinematic similarity and dynamic similarity. So this similarity actually are of, we can write here that three types are there. Three types of similarity. So three types of similarity. First one is, as I told you, geometrical similarity. First one is geometrical similarity, and second one is kinematic, and third one is dynamic. Actually, these are the three properties, or we can say dimensions: geometrical dimensions or geometrical quantities or properties, kinematic quantities or kinematic properties, dynamic quantities or dynamic properties of what? Of fluids. So these three similarities should be same between this model and the prototype. So that is called actually similitude of similarities. So first one, let me consider the geometrical. First one, let me consider this geometrical similarity. So in the geometrical similarity, actually, suppose we have created a model and that model was converted to prototype. So in the geometrical similarity, what are the things will similar? So in the geometrical similarity, basically we used to consider length. We used to consider length, or we can say volume, or we can say diameter, or diameter means area also can be considered, or length or width or breadth, something we can consider in that. So these are the parameters, or these are the, you can say, condenses in the geometrical similarities. So if you create any kind of model, in that obviously length will be there, or some kind of dimensions will be there. So this is nothing but dimension. So that dimension in the nothing is what kind of dimension? It may be linear dimensions. So the ratio actually in the geometrical properties or similarities, how we can write? So the ratio of all corresponding, we can write this is ratio of all corresponding, ratio of all corresponding, you can write linear dimensions, linear dimensions in model and prototype. Model and because we are talking about two things. Model and prototype should be same, or you can say are equal. Should be same, or we can say both are should be equal. So in that, as I told you, so we can consider like what is LM. This is, we can say, the length of the model. Length of model. Length of model. Similarly, I can write this is next is suppose dm. Dm is the diameter of model. Diameter of model. And similarly, I can write volume. So that is Vm. This is volume of model. And Am also I can write, this is area of the model. Area of model. And Bm, this is, we can write, this is breadth of model. Breadth of model. So these are the, as I told you, these are the some properties in the geometrical similarities. Okay, any kind of dimensions we need to consider, that's it. So here, yeah, volume, length, diameter. Now these are the for only models. Similarly, we need to consider for a prototype also. So in the prototype also we can write similarly we can write length of prototype or corresponding values of this, like diameter of the prototype and volume of the prototype and area of the prototype and breadth of the prototype. Okay, so as per this definition, we can write the geometrical similarities. How we can write the ratio of all these things. So how we can write the length of the prototype equal to length of the prototype by length of the model equal to, we can write breadth of the prototype by breadth of the model equal to, similarly we can write length, breadth and diameter we can consider. So diameter of the prototype divided by diameter of the model. This all should be equal. Okay, the ratio of all corresponding linear dimensions in the model and prototype should be equal. So length of the prototype and length of the model, breadth of the prototype by breadth of the model, diameter of the prototype by diameter of the model. So this one we can write actually LR. This is written as LR, and LR is equal to what? This is actually length ratio. This is actually, we can say length ratio, or we can say this is also scale ratio. This is also called as scale ratio. So both can be called. This is, now this is for one condition what I have written here. Now in the same way we can consider also area also, and we can consider volume also. This is about the linear dimensions. Now in the linear dimensions also you can consider the area ratio. So in the area ratio, area and volume ratio. So in the area and volume ratio, how we can write? So area, we can write area of the prototype to the area of the model. So area means what? Area means we can write one length and one more width or height, something we can consider. In that area need to be calculated. So here also we can write the length into breadth. So length of the prototype by length of the model into breadth of the prototype by breadth of the model. So anyway, what is this value of this length or to the length of prototype by length of model? That is nothing but LR. Similarly, breadth of this prototype by breadth of model, that is nothing but also LR. So this here also you can write what? Now LR into LR. So that is LR square. Okay. So this is area ratio, area of the model and the prototype. So that is LR square. Similarly, in the volume also you can write volume of the prototype by volume of the model. So here also similar things. I can write length, width, like breadth and diameter also can be considered. So in that I can write LR into LR into LR. That is nothing but LR cube. Or else we can write that is length by length cube. So in the volume we can consider any other thing like length, width, breadth we can consider, so that we can get LR cube. Similarly here also you can get length to the power cube, breadth to the power cube, or you can say diameter to the power cube also. So this is about volume. So these all conditions or properties what we have discussed, the similarity between this model and the prototypes of, this is about the as I told you, that is geometrical similarities. Similarly, in the kinematic similarities, again let's discuss about the kinematic similarity. So all are similar kind of things actually. Only we need to know what are the properties or parameters will come under the kinematic similarities. So in the kinematic similarities actually, like geometrical, how we have taken the length dimensions. So here in the kinematic similarities also the similarity of motion. Here actually we need to consider the similarity of motion. So similarity of motion of what? The similarity of motion of between model and prototype, because our comparison is between model and prototype. That is our main motto. So what are the differences, or if any differences was identified, then the model is not equal to the same prototype. So we need to assure that all these properties or similarities between this model and prototype should be same. That's why in the kinematic similarities, we need to consider similarity of motion, okay, between the prototype and the model. Okay, so similarity of motion between the model and the prototype. Now in the motion, which property or which parameter need to be considered? So we have seen in the dimension analysis time, the dimensional properties, we have considered the kinematic part is nothing but motion part. When we are talking about the motion, then we need to consider here, we need to consider two things. One is velocity, another one is acceleration. So these are the two things. One is velocity, another one is acceleration. So let's suppose we need to consider some kind of objects, some models we have created, and that was converted to prototype, and we need to verify the velocity of each positions. Each and every positions need to be checked in the prototype as well as in the model. So both should be similar. Similarly, acceleration also same thing. But as you know, see, up to now we have discussed only suppose and positions are there, some only one things we have considered. But here we know that this velocity and this acceleration, these are the vector quantities. These are vector quantities. So in the vector quantities, we know that we have two things need to be two things need to be similar, like magnitude as well as the directions. So as I told you, that two things need to be similar. One is magnitude, another one is directions. So along with the magnitude, we need to assure that the directions of flow also moving in the same directions or both are same. So here also we can consider the velocity of suppose P prototype. Suppose consider prototype at one point, first point, suppose we can consider point number 1. Similarly, point number 2, point number 3, many things we can consider. So another one is velocity of the prototype at point number 2, and this is two things, velocity as I told you. Similarly, acceleration. So acceleration of the prototype at point 1 and acceleration of the prototype at point number 2. Okay, this is I'm talking about any point in the models, in the prototypes. Similarly, in the correspondings, we can consider velocity of the model at point number 1 and velocity of the model at point number 2. Similarly, acceleration of the model point number 1, acceleration of the model at point number 2. Now, as per the definitions, what we can consider or what we can write for the similarities, we need to consider, actually we can write here what is the velocity of the prototype at point number 1 with respect to, we can write this is velocity of the model at point number 1. This is equal to velocity of the prototype at point number 2, and this is velocity of the model at point number 2, and this one also we can write VR. This can be written VR. So VR is the what? So VR is nothing but we can write velocity ratio. How we have written this is scale ratio or length ratio. Similarly, it is called velocity ratio. And for acceleration also we can write same thing, like acceleration of the prototype at point 1 with respect to acceleration of the model 1 equal to, we can write this is acceleration of the prototype point number 2 and acceleration of the model at point number 2. This equal to, also you can write AR, and this is called what? Acceleration ratio. This is called acceleration ratio. Okay, so we need to assure that as well as the magnitude, as in both the conditions we need to consider magnitude and directions. Magnitude and directions of this velocities of this, because velocity having some directions are there, accelerations, some directions will be there. So both models and prototypes should be same. Model and prototype directions of, so you can write here velocities, so should be same here. So this is about the kinematic similarities. Okay, and the last one we can discuss about the dynamic one. So this is also very, very simple, as I told you about that geometrical similarity and kinematic similarity. So dynamic similarity also very, very simple. So here in the dynamic, actually we need to consider some forces. We need to consider forces. The similarity, you can say similarity of forces between, so forces, so here also same thing like similarities. You can consider the similarity of forces between, again same thing, model and prototype. Model and prototype should be same. So as I told you, like all the directions of forces should be same for all the points. Like what are the forces can be considered when the fluid is flowing? Suppose what are the forces can be considered? Like number of forces acting in the fluid, such as we can consider, suppose force, inertia force. So inertia force, suppose of the prototype, inertia force of the prototype. So we can write this is inertia force. Inertia force here I am considering for of prototype. Similarly, we can consider the viscous force. We can consider the viscous force of the prototype. This is the, okay, this is viscous force of the prototype. Similarly, we can write another one. This is forces of gravity. Here also we can write this is gravity force of the prototype. And this is about the prototype. So similar kind of forces need to be considered for the model also. So what I can write here, similarly Fi model, and we can write this is viscous force for the model, and we can write this is gravity force for the model. Okay, now as for the definition, we can write as a dynamic similarities, we can write this is also similar like FIP, that means inertia force of the prototype divided by inertia force of the model. This equal to, we can write this equal to, we can write viscous force of the prototype with respect to viscous force of the model equal to, we can write this is gravity force of the prototype with respect to this is gravity force of the model. This all should be equal, and finally continue, we can write any kind of other forces also can be written here, and that is nothing but we can write Fr, and Fr is the force ratio. So here we can write Fr is the force ratio. Okay, so these are the three similarities what we have discussed. So here also we need to assure that all the directions of corresponding forces, what are the forces I told you, so direction of the all corresponding forces of all corresponding points. See here I have not mentioned the points. You can consider point 1, point 2, point 3, n number of points can be considered here. So the forces of all similar kind of forces, if every corresponding points, that should be same for model and prototype. So this is all about the similitude type of similarities in the dimensional analysis. So here what I have told you, explained you, is very, very simple. So if you want to highlight this. Like, see, first one, what we have discussed, the geometrical similarities. So in the geometrical similarities, we need to consider only dimension things. And while coming to the kinematic similarities, in the kinematic similarities, we need to consider the similarity of motion. So similarity in motion is nothing but velocity and acceleration. And in the dynamic similarities, we need to consider the dynamic similarity, we need to consider the forces. These are the three things we can remember so that we can easily identify what are the ratios are there between model and prototype and what are the similarities are there. So I hope you understand this concept. So this is very, very simple. If you are having doubts still, you can give a comment on the comment box. Thank you all.